Hey guys, welcome back to my new video. And today we are going to study a program in which we can calculate the sum from 1 to n. So this program is written in assembly language of the course Nan to Tetris. So it is not an x86 or ARM assembly language. It is of the hack computer. Now, uh, at RO means we access the register R0. R0 is accessed and a variable D equals the value M. Now, M here means the address, the value of the address 1 of RAM. So you can like visualize it as R1M is equal to the RAM of address 1. Or in this case it is R0, so here it is 0. And similarly if it is R0, and we can change all of these. Now uh, N and I are defined already, so the RAM of N is equal to the D, and this basically means N is equal to R0 and I is equal to 1. Now sum has been set to 0, so this actually means the RAM of uh, the address that is given is equal to 0. Here, a label is given for the loop because the loop starts here and ends here just before the stop. In the loop, add I is already defined, so another variable d is equal to m is given. Now at n, d is equal to d minus m. That is, d is set as d was first I. We have put it as I. Then minus n because m for at the rate n is going to be basically n. So this value is equal to d. Now at stop is accessed, and this statement means when d is greater than 0, because this is greater than, so when d is greater than 0 it will jump to stop, and stop is defined here as you can see. So this jumps to stop. Now d is defined as I minus n, so I minus n is greater than 0, then jump to stop. Again, we access the I element, the sum element, and in the sum element, we add d with I. So this is basically sum is equal to this is sum is equal to d is m, so I plus sum, and this basically means the sum is set to sum plus I. This just defines it. Both these are different, but m is equal to d puts the value in the RAM. Now I is defined again, so this basically means I is equal to I plus 1. Now we go to the loop and we say jump. So this means 0 semicolon jump means to be in an infinite loop. So infinite loop, so that program will not proceed further. Now whenever this condition is satisfied, when I minus n is greater than 0, this will come to here. The sum will be displayed as R1. We can store the value in R1, and finally it will end. Now I have also loaded this in the program CPU simulator. So let's say I put the R0th register as, let's say, 6. So this should technically calculate the sum from 1 to 6. So that is 1 plus 2 plus 3 plus 4 plus 5 plus 6. This is 21. The answer, the value in register R1 should be 21. So when I will run this, code and I will like put the pointer to fast. As you can see, the value in the R1 should be 21. So I have not entered this actually. So I have to rerun this. 1 second. Load. Now I will put the value 6 and then I will run this in the fast. So as you can see, the values are updating here rapidly, and this ends in an infinite loop. This is yellow, yellow. So as you can see, the R1 becomes 20. So that was the program for sum from 1 to n. Thank you.